Be greeted, guys. I hope that you are doing good. This is Elton from Maths and Science series. I hope that you are still practicing since term 4 is around the corner for you to write the final exams. So we'll be doing redox reactions. So for just a recap, you know what a reaction is. A reaction, it is when we are having the reactants reacting to form products, or reactants reacting to produce products, right? Now, that is how you know it, what a reaction is, right? It is when we are having reactants that are reacting to produce other things, which are products, right? Now, you know what a reaction is, but what does the term redox mean? Actually, the term redox, it is actually the combination of two terms, which is reduction and oxidation. So in a simplified manner or form, we're saying that it is redox reaction, but the real truth is oxidation, reduction, reaction. So it's very important for you to know it. So today we'll be doing the first part of the redox reaction, where we'll be talking about the oxidation and how to calculate the oxidation number. All right, we have, okay, since we're saying that this is what it is, an oxidation, reduction, reaction. It comes from this, or it is written like this, but now when it is combined, it is known as what? As a redox reaction. So it is very important for you to know how to define these two terms. So they will ask you to define oxidation. Oxidation, it is the loss of electrons, while reduction, it is the gain of electrons. The oxidation, it is the loss of electrons. Reduction, it is the gain of electrons. So sometimes they can say define oxidation in terms of electron transfer. It is still the same thing. This is how you are to define the oxidation, or the term oxidation and the term reduction. So it is very important for you to know how to define these two terms. Okay, we have something known as an oxidation number, which is the charge an atom would have if it was in a compound composed of ions. So it is very important for you to know how to define it, and you must know that oxidation number, it is calculated or can be calculated. So it is very important for you to know how to calculate it. So since this video is the first part, will be calculating or determining the oxidation number. So make sure that you follow, you understand, you pause the video if you didn't understand what is it. If you didn't understand maybe a certain part, you pause it, or you just start it afresh for you to understand what we are doing. So this is the first part of what we are doing today. So we'll be actually determining the oxidation number of the substances. So since you know, guys, as I said that oxidation number can be calculated, and this lesson is for showing you how to determine or to find the oxidation number. So these are rules for the allocation of oxidation number. That one stands for oxidation number. So the first point is that oxidation number for a monoatomic or diatomic or polyatomic elements, it is always 0. So you know that, so these are examples of monoatomic, diatomic and polyatomic. So helium, the first example, He, it is a monoatomic element. It means that its oxidation number, it is 0. Even zinc, since it is a monoatomic element, its oxidation number is 0. H2 is a diatomic, O2 is a diatomic, it is always 0. It means that if an element from a periodic table, it is not combined with other elements, they are oxidation numbers are 0. Group 1 elements have an oxidation number of positive 1. For an example, lithium has what? An oxidation number of a positive 1. It means that that positive or that exponent which is it is positive, it is the oxidation number of lithium. So group 1 elements have an oxidation number of positive 1. Then group 2 elements have an oxidation number of positive 2. For an example, magnesium have what? It has the oxidation number of positive 2, as well as calcium, and all the group 2 elements. They all have what? Their oxidation number of positive 2. Then the halogens, it is the group 7. It has the oxidation number, or all of them have oxidation number of negative 1. But there's an exception. There is an exception. But we'll focus on these and I'll show you how to determine the oxidation number of all the substances. And what you need to know, which is something that I didn't write there, that if an element from a periodic table it is not combined with other elements, its oxidation number is 0. And if, what you need to understand, if oxygen it is combined with other elements or other element, it means that its oxidation number it is always negative 2. It is very important for you to know that if oxygen is combined with another element, it means that its oxidation number it is negative 2. For an example, we know that since this is a diatomic element, because we can see that 2 it is repeated, the oxygen atom it is repeated twice or 2 times. It means that its oxidation number it is 0, because this is a diatomic and oxygen it is not combined another element or other element. So when it is on its own, it means that its oxidation number it is 0. But when we can combine hydrogen atom with the O or oxygen atom, it means that oxygen atom it will always have an oxidation number of negative 2. It is very important for you to know that. It is very, very important. So now we'll do some examples on how and where I'll be showing you how to determine the oxidation number. But these rules are very important. Make sure that you know them, you practice them, you know them now, because you cannot determine or you cannot find the oxidation number of any substance or elements if you do not know these rules. So make sure that you follow and understand whatever that I'm going to say or whatever that I said, because I can say that by you understanding what you see there on your screen, it means that you can answer, you can determine the oxidation number of any element. So let's do a few examples. Let's try and do these 2 examples. They say that determine the oxidation number of the underlying atoms. So we are to determine what? The oxidation numbers. We know that this is nitrogen, right? So the first thing which we are required to do, we'll say N plus, how many oxygen atoms do we have? 3. So we'll say 3 oxygen atoms equal to the net charge. This one, this -1, right? Then we'll say nitrogen atom plus 3. We know that whenever oxygen atom it is combined with another or other elements, its oxidation number it is always -2. So we put -2 here equal to -1. Where are we getting this -1 from? It is the net charge. Then we say n minus 6 equal to -1. Then we make n the subject of the formula. Will have a -1 plus 6, which is +5. So it means that the oxidation number of the underlying atom in the first example, its oxidation number, it is positive 5. It is positive 5. Let's do this one so we can understand what we were doing there. The second example will say, since we are having two nitrogen atoms, we'll make that subscript to become what? A coefficient. Then we say plus 3 oxygen atoms equal to what? It is the net charge. Here we equated negative 1 as the net charge because we are given the negative ion. Now here there's nothing. It means that if it was 2 here, we would put 2, but since we are having nothing, it means that we have to put 0, right? Therefore we say 2 nitrogen atom plus 3 oxygen atoms, and we know that when an oxygen atom is combined with another element or elements, it means that its oxidation number, it is always negative 2. Then we equate it to the net charge, which is 0, since we are not given anything there. I hope you are following. So 2 nitrogen atoms minus 6 equal to 0. Therefore we'll say 2n equal to positive 6. Then we make n the subject of the formula by dividing both sides by 2. Now n equals positive 3. It means that the oxidation number of the underlying atom N2 or a nitrogen atom in the second example, it means that its oxidation number, it is positive 3. So it is very important for you to know this. It is very, very important. Now, if we were not given this negative ion there, it means that the net charge here will be 0. But now we are given what? Minus 1 or minus. But we know that it is minus 1. We equate it to negative 1. I don't know if you understand this, but it's very important for you to know it or to know how to determine the oxidation number. Okay, let's continue with these examples. So for us to determine the oxidation number, it means that we have to make these subscripts to become what? To become, what are these coefficients or mole ratios? It means that here we are required to do what? To find the oxidation number of the underlying atoms, which is P or phosphorus. Therefore, we'll make these 3 as a subscript of hydrogen to become its coefficient, plus P or phosphorus plus 4 oxygen atoms equal to what is our net charge? Since it is not written there, or if it was negative 3 or 3 minus, we would say it is negative 3, the net charge. But now since we are not given the net charge, we say the net charge is 0. Therefore we say 3. We know that we said that the group 1 elements have what? The oxidation number of positive 1 only if hydrogen is combined with other elements. I don't know if you understand that, but if it was hydrogen only, we will say its oxidation number is 0, since it will be a monoatomic element, plus phosphorus plus 4 negative 2. Why are we putting negative 2 there? Because we know that when oxygen atoms are combined with other elements, they always have an oxidation number of negative 2. Therefore, say 3 plus phosphorus minus 8 equal to 0. Therefore, we make P the subject of the formula. But first, let us simplify the like terms. We are having negative 5 negative 5 plus P equal to 0. Then we take the 5 to the right hand side. We'll have positive 5. It means that the oxidation number of phosphorus, it is positive 5. it is positive 5. So it is very important that you guys know this. So if I can place all these oxidation numbers here, we know that here it is 1, here it is 5 plus, here it is 2 minus. Alright, but that's not important in this part. We'll do it in the second part, on the second part. Now here we are to determine the oxidation number. We'll say 2s plus 10 fluorine equal to the net charge. What is the net charge? Since we're not given it, it means it is 0. But if it was 3 plus, we'll say it is 3, right? Yes, so 2 sulfur plus 10 fluorine. We know that halogens, they have what? They have the oxidation number of -1. Where there's F, I substitute -1 because F, it is an example or an element in the halogen or group 7. So it is very important for you to know the groups and the elements on the groups from the periodic table. So 2s minus 10 equal to 0. Then we make S the subject of the formula, we divide by 2, we divide by 2. Then we have S as positive 5. It means that the oxidation number of sulfur atom, it is positive 5. I don't know if you are following. Now if we were to put them on the compound, we would say, since we got the oxidation number of sulfur is positive 5, we would put a 5 plus or plus 5. Then here, since we know that the fluorine atom always, since it is what? A halogen, it means that it has what? An oxidation number of -1. I hope we are following. Make sure that you pause the video, you try to do it on your own, then you just mark yourself. Let me say we were to determine the oxidation number of H or hydrogen atom. So we'll say that 2H plus oxygen atom equal to 0, the net charge, since we are not given any, right? So we'll say 2H minus 2. We know that when oxygen atom, it is combined with other elements, it means that its oxidation number is always -2. We equate it to 0. We say 2H equal to positive 2 to make H the subject of the formula, right? And we have H as positive 1. So it is very important for you to know how to find or to determine the oxidation number. Let me check maybe the second of the last. Let me say we have Cr2O7 2 minus. Then we are asked to find the oxidation number of chromium in these dichromate ions. We would say 2Cr2 plus 7 oxygen atoms equal to the net charge, it is -2. This is -2. So 2Cr, no, we don't put the 2 there, so plus, because we have to make this subscript to become the coefficient. That is what I've done there. Plus 7. Then what is the oxidation number of oxygen atom when it is combined with other elements? It is -2, equal to this -2, right? So this is the net charge. It's not just the oxidation number of oxygen. So 2Cr minus 14 equal to -2. Then you say 2Cr equal to -2 plus 14. We are going to have positive 12, right? That is why I put positive 12 there. Then I divide by 2, I divide by 2. I have Cr as positive 6. It means that the oxidation number of Cr is positive 6. Now I put it where the Cr, which is 6 plus. Let me just put it slightly there. So this is how we are determining the oxidation number. So it is very important, guys, for you to know how to do this one. So let me just give you this one, then after that you will try to do it on your own. Let me say you have Cr2O4 2 minus, then they ask you to find the oxidation number of Cr. It will be 2 Cr plus 4 oxygen atoms equal to the net charge, right? Therefore 2 Cr plus 4, we know that when oxygen it is combined with other elements, it is always its oxidation number is always -2, equal to the -2, which is the net charge. Therefore we'll say 2 Cr minus 8 equals -2. Therefore 2 Cr equal to minus 2 plus 8, it will be +6, right? Because if you do something like this, minus 2 plus 8, you just punch that on your calculator, it is going to give you +6. Divide by 2, divide by 2. This cancels that, and Cr, it is +3. Then you put it there, 3 plus. So it is very important for you to know how to find it. Let me just give you 2 of them, then you will try them, then you will see if you are understanding this or not. So I'll just give you one example, then you leave your answer on the comment platform. So I won't give you many of them because it can make things to be complicated. So I'll just give you one which can make you to do it to send your answer on the comment platform. So H3PO4, H3PO4. So find the oxidation number of H3 or of H, the underlined atom. So please do not forget to subscribe, like, share and comment. So this was the first part of the redox reaction. So if you continue subscribing, sharing, commenting, we promise that we are going to do the second part of the redox reaction, which is to determine the oxidizing agent as well as the reducing agent. So thank you, guys. Thank you to those who are subscribing, to those who are supporting the channel. Please make sure if you haven't subscribed yet, please do not forget to do so. And if you subscribe, please make sure that you press on the notification bell so that you can be notified when you upload new lessons. Thank you.